Well, what AREVA is doing, and I'll address that, and then let me just address the next generation nuclear plant briefly at the end of that, is that, you know, in the U.S., our advanced reactor interest is the high temperature gas cooled reactor. The AREVA total has been involved in gas reactors for the last 40 years. Our progenitors developed the pebble bed reactor. In the last 15 years, been working both in partnership with GA and with others in developing the prismatic reactor as both. So we have both versions that we've been interested in. We prefer the prismatic for the application in the U.S. And so we are maintaining participation in the Next Generation Nuclear Alliance in the U.S. in order to further that concept as outlined in the 2005 Energy Policy Act. In France, we're the flagship advanced project is, of course, the Astrid reactor, a medium-sized sodium-cooled reactor, which is hoped to be started up in 2021. And that's quite a ways down the road now in basic design, and there'll be a decision based upon review of that design in 2012 whether or not to proceed with it as it stands. So that's a key effort in the reactor side. We would regard Gen 3 reactors as advanced, frankly, given that there's none operating yet. There's a number in construction. We have 4 in construction, but none operating yet. And the evolutionary power reactor, the AP1000, has some in construction and none operating yet. So until those are actually operating, we have experience with this latest generation, and ESBWR is close and just starting, we hope, and for them in a couple of places. So I would hesitate to call any reactor that has never run not advanced. It's designed to be advanced, and we hope this more robust Generation 3 reactors get going. But in terms of the Generation 4 reactors, such as the Astrid sodium-cooled reactor or the Next Generation Nuclear Plant, which is a high-temperature gas-cooled reactor, they both have licensing bases that, well, I should say they don't have licensing bases in the U.S. and require an extraordinary amount of effort to get to a position of deploying, and a lot of time, as some of discussion occurred yesterday. So whatever the concept, let's take the Next Generation Nuclear Plant, it's going to, from the time you start seriously working with the NRC and defining the design that you want to license, it's going to take about 12 years to get a license. And that's the way it is with the current licensing regime. So that says starting today, if we got serious about NGNP, we could have it up and running in 2023. That would say that if that works well and everything that we thought we tested and proved works well, then after that prototype, you might have commercial deployment in earnest in about 2030. So a business case to have broad-scale deployment of an advanced reactor in 2030 has got to have a pretty good return to justify the hundreds of millions and billions it takes to get from here to there. So that's where we're patiently working our way through.
Would there be an attempt to do any of this in another country where you might not have the regulatory lag or as much of a regulatory lag?
Well, several thoughts there. One is that the NRC certification is pretty much a gold standard, and so I think in most countries they would prefer to have that. Two, I think we're going to see post-Fukushima that everybody's going to say, are there differences in standards around the world, and if so, should we not adopt the best of those and not the least of those? And so I don't really think there'll be much difference going forward.
Right. Thank you very much.